Hello, this is Professor Neshiba again, and I'm here to help you out with the second part of the in-class exercise on Excel. This has to do with the decomposition of NO2, and I've set up my spreadsheet, and in this way you should probably do the same thing. I've set aside boxes for the two rate constants, K1 and K2, and here's a theory column for first order, and I'm setting up the theory column for second order in two steps for reasons that you'll see in a little bit. So I think you should do that and come back. Okay, I assume you're back. Let's see what the theory says about first order, or remind us. Here's equation 3 in the handout. This is just the equation that you use for ozone right there. So I will implement that one. That was an equals. And my initial concentration, now look at this, my initial concentration is different from ozone. It's 0.01, so 0.01 times exp of the minus, and I want to have K1, so I'll put K1, and times the time. There we go, that's that. And as before, I don't want K1 to have relative addressing. I want that to be an absolute address, so when I fill down, it doesn't move. There we go. And I will double click on this, and we got that. Let's see about graphing. I'll click over here, and as before, I'll go to source data. I'm going to add a column. This will be first order. Click in that X box to pick up the times. Click on the Y box to pick up the first order theory. And there we go. And also, as before, probably we want to change that so I don't have any marker, but I do want a line. So we'll go it that way. And there we go. Now, of course, looks like my K constant is not quite right on this, so you'll probably want to adjust your K so you get a good match with the experiment. How about the second order part? Well, the second order theory, to go back to here, I'm going to do it in two pieces. It's this equation right here. That's the integrated rate law for second order decay. I'll do the first part here, which is in the parentheses, and then in a second column, we'll take 1 over that. All right, and I think maybe you should pause and try to do the first part yourself. Okay, here's my attempt at this. I will say that's equal to, let's see, it was 1 divided by my initial concentration, 0.01, and plus K2, that's K2, times the time. That's the same time column as before. I'll hit return. And just as before, I want to fix K2 so it doesn't fill down. And that looks pretty good to me. Now for my fill down, I double click on there. Now let's see, I have one more step on here. That was 1 over, so I need to invert this so that I actually get the concentration of NO2. Now I'm going to take 1 over the column that I just did so we can get the concentration of our NO2 over time. So that's pretty easy. I will say 1 over column D. Why don't you give that a shot? Okay, here we go. I'll say equals 1 divided by that column. Okay, and I want that to happen all the way down, so I'll just double click that. Now I want to make a graph of what this looks like. So as before, I'll go to source data. Let's see, I want to add another one. This will be second order. X values, same, put the times in. Y values, now I want these values, these NO2 concentrations. I think that looks good. Well, I don't have a very good value. It looks like it's not a terribly good match, but first let me go ahead and I want a line, just as we did before. Oh, maybe I should have given it a different color. I don't want to have a marker on it. Oh, that's looking pretty good to me. So now we're ready to do a little bit of science on this. I think it looks like my K value is, I think it's too small. The reaction needs to go faster. So how about 0.02? Well, that's looking a little bit better. How about if I wanted to fix the first order result? Looks like that first order k value is too big. How about 0.005? That's looking a little bit better. Okay, and so that should get you through the second part.